I'm Jonathan Tomkin from the University of Illinois. This week we're talking about weather and climate. Weather and climate aren't the same thing, and I'd like to illustrate that with an example. As you can see in this picture, there are three different images of the alma mater, a statue on the University of Illinois campus, at different times of the year. And clearly, Urbana-Champaign, where the university is located, experiences very different weather in the different seasons. Looking at these three pictures, can you estimate what you think the average high temperature for Urbana-Champaign is throughout the year? Do that now before we move on to the next slide. There's another way that we might attempt to estimate the temperature over the year, and that's by sketching on this graph. Now, if you look here, you'll see that there is, on the y-axis, we have degrees in degrees Fahrenheit, and on the x-axis we have the times of the year, starting in January and then the middle of July, and then returning to January again at the end. Using this as a template, can you sketch what you think the high temperature would be throughout the year and how it might change? If you're not from North America and you want to convert into Celsius, remember that at 0 degrees Celsius, Fahrenheit is 32, and then each degree Celsius is about 2 degrees Fahrenheit. So if we were to go to 10 degrees Celsius, that's roughly 50 degrees Fahrenheit. In this slide, we're looking at some actual data. As you can see, there is a blue line which is connecting the daily high temperatures from day to day across the year. This is for 2009. Notice that there is a lot of variation. Winter days varied enormously, in some cases by as much as 50 degrees Fahrenheit day to day. That's about 25 degrees Celsius. And even in the warmer months, there was a large amount of variation. Some days in June had highs that were 30 degrees higher Fahrenheit than other days. Your sketch probably looked more like this orange line, and that's the average of the daily highs that you might expect for those days. So on average, we expect a July day in the Northern Hemisphere to be warmer than a January day in the Northern Hemisphere. And of course, the reverse is true if you're in the Southern Hemisphere. The green line is the average for the whole year. And of course, this is the question I started this talk with. And as you can see, it's about 60 degrees Fahrenheit. In fact, it's 61 degrees Fahrenheit. That's about 15 degrees Celsius. The blue line is the data, and this is changeable in a single year. But the green line and the orange line are averages. So the blue line is in fact measuring weather, whereas the average data, the green line and the orange line, are measuring the climate. So in this series of lectures, we normally talk about climate, and it's very important that we're aware of the distinction. So we can define weather and climate like this. Climate is the long-term average of the weather, or we could say weather is short-term variation in the climate. If climate changes, that means that the weather will change too, so it's very important that we know what the climate is doing. In the next lecture, we'll look at the fundamental forces that determine what the climate average is.
Produced by OCE Atlas Digital Media at the University of Illinois, Urbana-Champaign.